How do you add matrices?
It is pretty easy to add matrices. For example, for 1 2 plus minus 1 minus 2, you add the matrices, or in this case, row numbers, simply by adding the corresponding terms in each matrix. Thus, the matrix of 1 2 plus minus 1 minus 2 equals 1 2 1 2 2 2 equals 0 0. All that remains of the once great Maya civilization are remarkable ruins such as these in the Yucatan Peninsula of Mexico. They are reminders of an advanced culture that had made great strides in mathematics, including the use of matrices. The image bank / Getty Images.
What do these philosophies tell about the state of modern mathematics and logic?
Like many abstract and complex studies, philosophies come and go. Some are good, some seemingly on the mathematical fringe. But they also show us that there is currently no single philosophy that truly defines our mathematical and logic foundations, especially when it comes to combining both mathematical knowledge and the application of mathematics to physical reality.
Who invented catastrophe theory?
Catastrophe theory, or the study of gradually changing forces that lead to so-called catastrophes or abrupt changes, was popularized by French mathematician René Thom. 1923 to 2002, in 1972. Unable to use differential calculus in certain situations, Thom used other mathematical treatments of continuous action to produce a discontinuous result. Although it is not as popular as it once was, it is often used in biological and optical applications.
What is an expression in mathematics?
An expression in mathematics is a statement that uses either numbers, variables, or both. For example, the following are all mathematical expressions: y4645x x74 plus 5x, 32, x plus 4x, 7x. In order to write an expression from a written mathematical problem, one has to interpret the text. For example, if one person weighs 100 pounds and another weighs y pounds, the expression for their combined weights would be 100 plus y.
What are the arithmetic mean and geometric mean?
The average, in general, means the average value of a group of numerical observations, or the statistical measure of the arithmetic mean, or just the mean. On a scale of measurement, it is usually the place in which the population is centered. Numerically, it equals the sum of the scores divided by the number of scores. For example, the sum of 3, 7, 10, 15, and 25 is 60, thus, the mean is 60 divided by 5, or 12. The geometric mean is another type of mean. For two quantities, it is the square root of the quantities' product. The notation is for n quantities, and the geometric mean is the nth root of their product.
What is the discriminant of a quadratic equation?
In the quadratic equation x2 plus bx plus c equals 0, the value of b2 for ac is the discriminant. The same numbers and letters that are under the square root sign of the quadratic formula. This is actually the products of the squares of the polynomial root differences. In other words, this quantity characterizes certain properties of the quantity's roots. The discriminant is often used for such mathematical concepts as metrics, modules, quadratic fields, and polynomials.
What is a matrix?
A matrix is a concise way of representing and working with linear transformations. Also, it is a rectangular array or grid of numbers or variables that allows the user to perform certain mathematical operations. They are usually symbolized as large parentheses or two large pair of parallel double lines surrounding the array of numbers or variables. These numbers can be manipulated to solve systems of equations or problems with many different variables or numbers by addition, subtraction, multiplication, or other methods. Each row and column of a given matrix must have the same number of elements. Anytime one has a list of numbers, or a table of numbers in a specific order. Concerning anything at all, prices, grades, populations, coordinates of points, production tables, it can be considered to be a matrix. When the idea of the matrix was first conceived, its development dealt with transformation of geometric objects and solution of systems of linear equations. Historically, the early emphasis was on the determinant, see below, not the matrix. Today, especially in linear algebra, matrices are considered first.
What is Ohm's law?
Ohm's law is important to the field of electrical studies. It states that direct current flowing in a conductor is directly proportional to the potential difference between its ends. First summarized by German physicist George Simon Ohm, 1789 to 1854, it is usually seen in formula form as V equals IR, or I equals V/R, in which V is the potential difference, voltage. I is the current, also written in some texts as I, and R is the resistance of the conductor. This can also be written in terms of electric quantities. voltage equals current x resistance, and with units of measure, volts equals amps x ohms.
Can all quadratic equations be solved by factoring?
Don't be fooled, not all quadratic equations can be solved by factoring. For example, x23x equals 3 is not solvable with this method. One way to solve quadratic equations is by completing the square, still another method is to graph the solution. A quadratic graph forms a parabola, a U-shaped line seen on the graph. But one of the most well-known ways is by using the quadratic formula. For example, if we want to find the roots of the polynomial x2 plus 2x7, we can replace the corresponding numbers from the initial equation into the quadratic equation x2 plus bx plus c equals 0. Thus, a equals 1, b equals 2, and c equals minus 7.
What are lateral surface areas?
In many mathematical texts, the lateral surface area, L A, is given along y there instead of the surface area, SA. This type of area is the surface area of a three-dimensional figure, excluding the area of any bases. In other words, the lateral surfaces are the side faces, or surfaces, of a solid, or any face or surface that is not a base, or bottom of a figure.
What was the gambler's ruin?
In the problem, if a player begins with $10 and intends to play the game repeatedly until he either goes broke or increases his holdings to $20. The question asked is, what is his probability of going broke? The answer involves quite a bit of probability computation. For more information about the gambler's ruin, see recreational math.
What is the Fibonacci sequence?
Italian mathematician Leonardo of Pisa, c. 1170 c. 1250, also known as Fibonacci, or son of Bonaccii, although some historians say there is no evidence that he or his contemporaries ever used the name. May be known for helping to introduce Hindu-Arabic numerals to Europe, CP 70, but he also is famous for the sequence of numbers he discovered. This sequence initially pursued as an exercise to determine how fast a pair of rabbits can reproduce per year is formed by adding the two preceding numbers to find the next number, starting with a pair of ones. Thus, the Fibonacci numbers in the sequence are 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, and so on. or 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5, 5 plus 3 equals 8, 8 plus 5 equals 13, 13 plus 8 equals 21, 21 plus 13 equals 34, 34 plus 21 equals 55, 55 plus 34 equals 89, 89 plus 55 equals 144, 144 plus 89 equals 233, 233 plus 144 equals 377, and so on.
How did some ancient cultures refine their calendars?
There were many different ways that various ancient cultures refined their calendars. And all of them entailed some type of mathematical calculation. One way to measure the length of a year was by using a gnomon, or a structure that casts a shadow. For more about gnomons and sundials, see p. 57. This was based on the apparent motion of the sun across the sky, with the shadow not only used to tell daily time but also to determine the summer solstice, when the shadow created by the gnomon would be at its shortest at noon. By measuring 2 successive summer solstices and counting the days in between. Various ancient cultures such as the Egyptians developed a more detailed calendar and, as a bonus, determined the exact times of the solstice. Around 135 BCE, Greek astronomer and mathematician Hipparchus of Rhodes, c. 170–c. 125 BCE, decided to compare his estimate of the vernal, spring in the northern hemisphere, occurring in March, equinox with that made by another astronomer about 150 years earlier. By averaging the number of days, he estimated that a year was equal to 365.24667 days. A number only off by about 6 minutes and 16 seconds.
What is the story behind the Mersenne primes?
Mersenne primes, or Mersenne numbers, are connected to prime numbers. They come in the form of 2p1, in which p is a prime, or, to put it another way, when 2p1 is prime, it is said to be a Mersenne prime. Centuries ago, many mathematicians believed that numbers from the form 2p1, they actually used the form 2n1, which is the same as the 2p1 used today, were prime for all primes p. By the 16th century, it was proven that 211 1 equals 2047 was not prime. By 1603 Pietro Cataldi, 1548–1626, correctly discovered that p equals 17 and p equals 19 were both prime. But he was wrong to add 23, 29, and 37 to his prime numbers list. Soon, others discovered his errors, including French mathematician Pierre de Fermat, 1601–1665, in 1640, and Swiss mathematician Leonard Euler, 1707–1783, in 1738. The hunt for primes continued. The name Mersenne actually came from the French priest Father Marin Mersenne, 1588–1648. who in 1644 referred to such numbers in the preface to his book Cogitata Physica Mathematica. He believed that these special primes were p equals 2, 3, 5, 7, 13, 17, 19, 31, 67, 127, and 257. But like earlier attempts at determining prime numbers, many of Mersennet's numbers were in error. It took 3 centuries more to check Mersennet's range of numbers, and by 1947 the correct list of Merssennet primes were p equals 2, 3, 5, 7, 13, 17, 19, 31, 61, 89, 107 and 127. Interestingly enough, even though Merssennet incorrectly stated that certain numbers belonged to this group, he probably didn't verify all the numbers on his list. His name is still attached to these numbers.
What is the definition of a conic section?
This family of curves first discovered, as far as we know, by the ancient Greeks is generated by planes intersecting, cutting into, a cone. The resulting feature depends on the angle between the plane and the axis of the cone, with none of the planes passing through the endpoint, vertex, of the cone. Each plane that cuts a cone creates a two-dimensional figure called a section. Thus the resulting figures are called conic sections or conics. In general, the possible resulting surfaces are a sphere, the cut perpendicular to the axis, ellipse, or the circle as a special case, a cut moderately inclined to the axis, parabola, a cut parallel to one of the straight lines that generate the cone, and hyperbola. Using two cones tip to tip, the cut even more steeply inclined than all the others.
How did Pierre-Simon de Laplace apply mathematics to astronomy?
French mathematician, astronomer, and physicist Marquis Pierre-Simon de Laplace, 1749–1827, was one of the first to work out the gravitational mechanics of the solar system using mathematics. In his Mécanique céleste, celestial mechanics, Laplace translated the geometrical study of mechanics used by Isaac Newton to one based on calculus, or physical mechanics. He also proved the stability of the solar system, but only on a short time scale. Laplace is also known for his theory about the formation of the planets. He believed they originated from the same primitive mass of material, a theory now known as Laplace's nebular hypothesis. His other studies included major contributions to differential equations and to the theory of probability.
How are studies of fluid mechanics used today?
The list of engineering uses of fluid mechanics in the modern world seems endless, and no wonder, since it is one of the most widely applied areas of mathematics and engineering. Some of today's uses of fluid mechanics in various fields include Understanding the movement of molten liquid, rock, or lava, in volcanic eruptions, studying the flow of air over objects to help design airplanes. The space shuttle, and even spacecraft that fly through the atmospheres of other planets. Airflow studies in the automobile industry to design cars with more aerodynamic profiles, analyzing the ups and downs of the stock market. Examining natural hazards, such as snow conditions that result in an avalanche. Interpreting turbulent flow in sewer and water pipes, and in river channels. Studying complicated flow of weather patterns in the atmosphere, researching the effects of gravity, and other, waves in space. And using fluid mechanics applications to study the deep oceans and coastal shorelines, including waves and currents.
What are survivorship curves?
Survivorship curves record and plot the fate of the young and their chances of survival in key age categories. Significant factors affecting all populations are birth rates, death rates, and longevity. By recording the numbers of births and deaths over a period of time, researchers can determine the average longevity of organisms in each age class. These numbers tell a great deal about a population. There are three basic survivorship curves. Type I curves represent species that have offspring with a high survival rate, with most living to a certain age and then dying. Humans are an example. Type II curves represent organisms with a steady death rate from the time they are born or hatch until they die. Their survivorship varies and includes such species as deer, large birds, and fish. Type III curves include those organisms that have a low survivorship shortly after being born, but with a high longevity for the individual organisms that survive. Maple and oak trees can be included in this category.
What are dice?
Dice are small cubes usually used in games of chance. Each dice is the plural, has 6 sides numbered with dots from 1 to 6. The dots are placed on the cube so that the sum of dots on opposite sides equals 7. The total number of dots on each die equals 21. They are mostly associated with certain types of games, with the simplest involving a player, or many players, who throw, or toss or roll, the dice for the highest sum. Dice have been around for more than 3,000 years, with evidence found in ancient Egyptian tombs, Chinese burial chambers, and the ruins of Babylon. The Greeks and Romans were avid users of dice and associated games, and they have been popular from the Middle Ages on. Dice have been made from many materials, including ivory, bone, wood, metal, and eventually plastic. Not all dice are square. The cube, or hexahedron, belongs to the group of 5 Platonic solids, or solids formed by regular polygons. Thus, other Platonic solids have also been made into dice, including shapes, Polyhedra, such as tetrahedrons, octahedrons, and dodecahedrons, which are used for certain types of games. For more information about Platonic solids and polyhedra, see geometry and trigonometry.
How is a dimension described in mathematics?
In mathematics, a dimension is the number of coordinates, or parameters, required to describe points of or even points on a mathematical object, usually geometric in nature. The dimension of an object is often referred to as its dimensionality. For more about coordinates, see elsewhere in this chapter. For more about dimensions and science, see Math in the Natural Sciences. Each dimension represents points in space from a single to multiple points. The concept of dimension is important in mathematics, as it defines a geometric object conceptually and/or visually. In fact, the idea of dimensions can even be applied to abstract objects that can't be directly visualized. Mathematicians most often display such dimensions on graphs using a single point. For example, x, to represent one dimension, 2 points, usually x and y, or an ordered pair. To represent 2 dimensions, and 3 points, usually x, y, z, for 3 dimensions. The 4, and higher, dimensional analogues of 3-dimensional objects often retain the prefix hyper dash, such as hypercube and hyperplane. The basic geometric structures of higher dimensional geometry, the line, plane, space, and hyperspace, all consist of an infinite number of points arranged in specific ways.
What was the scandal between mathematicians working on cubic and quartic equations?
The early work on cubic equations was a tale of telling secrets, all taking place in Italy.
How is air density related to air pressure?
The expression thin air is actually a reference to the atmosphere's density, or how thick the air molecules are near the Earth's surface. In chemistry terms, density is merely the mass of anything, including air, divided by the volume the mass occupies. For example, the density of dry air at sea level is high, mainly due to the pull of gravity. In metric system terms, sea level density is about 1.2929 kg/m3, or about 1/800 th the density of water. But as altitude increases, the density drops dramatically. Mathematically speaking, the density of air is proportional to the air pressure and inversely proportional to temperature. Thus, the higher up one is in the atmosphere, the lower the air pressure and the lower the air density. There is somewhat of an athletic advantage to higher elevations at least for players of such sports as football and baseball. Because the air density is lower, a ball thrown in high elevation places like Denver, Colorado, will travel even farther than a ball thrown in a close to sea level city, such as Miami, Florida. In fact, the air at the Denver Stadium allows balls to travel almost 10% farther.
What are the probability and odds of drawing a certain card from a deck?
The probability of an event is usually described as the chances for the event to occur over the total chances for the event to occur, chances for/total chances. In the case of a deck of 52 cards, the probability of drawing a king from the deck is 4/50 seconds equals 1/13 equals 0.077, or 7.7%. As seen above, the odds, or the ratio of chances for to chances against, chances for, chances against, can be found by the formula, total chances equals the chances for plus chances against, or total chances equals chances for plus chances against, or chances against equals total chances for. Thus, the odds of picking a king from a deck of 52 cards is 4/52 4, equals 4/48 equals 1/12.
What were the major reasons for 16th century advances in European mathematics?
There are several reasons for advances in mathematics at the end of the Middle Ages. The major reason, of course, was the beginning of the Renaissance. A time when there was a renewed interest in learning. Another important event that pushed mathematics was the invention of printing, which made many mathematics books, along with useful mathematical tables, available to a wide audience. Still another advancement was the replacement of the clumsy Roman numeral system by Hindu-Arabic numerals. For more information about the Hindu-Arabic numerals, see Math Basics.
What are multiplication tables?
Multiplication tables are just what the name implies, a table of multiplication. Most of these tables have a specific purpose, mainly to multiply numbers in the rows and columns by each other to find a product. One of the simplest multiplication tables deals with the whole numbers.
What does E represent in terms of logarithms?
No, E is not the code name in a James Bond movie. When talking about logarithms, or logs, in the majority of mathematical circles, it means the base of the natural logarithm.
What is a Diophantine equation?
He first mention of Diophantine equations was by Greek, Hellenic, mathematician Diophantus, c. 210 c. 290 CE, in his treatise Arithmetica. He solved equations with several variables for integral solutions, what we call Diophantine equations today. For more about Diophantus in history, see History of Mathematics. These are represented by one equation with at least two variables, such as x and y, and whose solutions have to be whole numbers, or integers. These equations either have no solutions, or an infinite or finite number of solutions. Diophantine analysis is the mathematical term for how to determine integer solutions for such algebraic equations.
How do geologists use angles to understand rock layers?
Mathematics, especially geometry, is instrumental in understanding rock layers. In a branch of geology called stratigraphy, scientists measure angles and planes in rock in order to know the location of certain rock layers and the possible geologic events that affected the layers over time. In particular, geologists measure strike and dip. Strike is the angle between true north and a horizontal line contained in any planar feature, such as a fault, usually caused by an earthquake, or inclined bed, often caused by the uplift of hot molten rock around a volcano. Dip is the angle at which a bed or rock vein is inclined to the horizontal. It is measured perpendicular to the strike and in the vertical plane, as opposed to the strike's horizontal line.
Who was Hipparchus?
Hipparchus of Rhodes, also seen as Hipparchus of Nicaea, as he was born there, c. 190 c. 120 BCE, was one of the greatest Greek astronomers. A partial list of his discoveries includes, being the first to discover the precession of the equinoxes, compiling an extensive star catalogue, assigning magnitudes as a measure of stellar brightness, and calculating the length of the year to within 6.5 minutes of the correct value. His planetary models were mathematical, not mechanical. And although Hipparchus did not invent it, he was probably the first person to systematically use trigonometry, which was a necessity for most of his discoveries.
What were the two fundamental ideas in the development of numerical symbols?
There were two basic principles in the development of numerical symbols. First, a certain standard sign for the unit is repeated over and over, with each sign representing the number of units. For example, 3 is considered 3 in Roman numerals. See the Greek and Roman mathematics section below for an explanation of Roman numerals. In the other principle, each number has its own distinct symbol. For example, 7 is the symbol that represents 7 units in the standard Hindu Arabic numerals. See below for an explanation of Hindu Arabic numbers. For more information, see Math Basics.
What is a simulation?
A simulation is an imitation of some real event or device. It is often used interchangeably with the word modeling, as in modeling of natural systems. A simulation tries to represent certain features, or behaviors, of a complex physical system based on the underlying computational models of the phenomenon, environment, or experience. Simulations are used to understand the operation of real-world, practical systems. For instance, the modeling of natural systems such as the human body. They can be used to simulate a certain type of technology, such as a new type of airplane. Or model an engineering concern, such as the stability of a building during an earthquake. Simulators, interactive, physical devices that simulate reality, are also part of simulation. For example, space shuttle simulators are used to help astronauts understand the intricacies and various scenarios associated with flying the space shuttle.
What are the conditions in reference to differential equations?
In general, there are two conditions when discussing differential equations.
What is a slide rule?
The slide rule is a ruler-like device with logarithmic scales that allows the user to do mathematical calculations. It is portable, with the most common slide rules using 3 interlocking calibrated strips. The central strip can be moved back and forth relative to the other two. Calculations are performed by aligning marks on the central strip with marks on the fixed strips, then reading marks on the strips. There is also a see-through sliding cursor with a hairline mark perpendicular to the scales, allowing the user to line up numbers on all the scales. Sadly for mathematical traditionalists, the use of the slide rule was eventually overtaken by the pocket calculator by the mid-1970s. But in other ways, this development was welcome. The slide rule had two major drawbacks, especially for calculations in mathematics, engineering, and the sciences. It was not easy to add with the device and it was only accurate to 3 digits.
How are the simplest angles classified?
Angles are usually expressed in terms of rotation, in which a full rotation is equal in most cases to a 360-degree circle. Half of a full rotation is called a straight angle. A quarter of a full rotation is called a right angle, 90 degrees. An angle less than a right angle is called an acute angle. An angle greater than a right angle is called an obtuse angle.
What is a numeral?
A numeral is a standard symbol for a number. For example, X is the Roman numeral that corresponds to 10 in the standard Hindu-Arabic system.
What is a percent?
A percent, using the symbol percent, is the ratio of one number to another. Percents are quantitative terms in which n% of a number is n1/100ths of the number. They are usually expressed as the equivalent ratio of some number to the number 100. For example, the ratio of 25 to 50 means the number 25 is 50% of 50. They are not true numbers. Thus, percents can't be used in calculations, such as addition or multiplication. But operations can be conducted with percents when they are translated into ratios and fractions. Such as 25% is equal to 0.25 or 1/4.
How did our present day become divided into hours, minutes, and seconds?
Divisions into hours, minutes, and seconds probably began with the Sumerians around 3000 BCE. They divided the day into 12 periods, and the periods into 30 sections. About 1000 years later, the Babylonian civilization, which was then in the same area as the Sumerians, broke the day into 24 hours. Europe around 20,000 years ago recorded days between successive new moons. Another hypothesis states that the measurement of time dates back some 10,000 years, which coincides with the development of agriculture, especially in terms of when to best plant crops. Still others point to timekeeping evidence dating back 5,000 to 6,000 years ago around the Middle East and North Africa. Whatever the true beginnings, most researchers agree that timekeeping is one of those subjects whose history will probably never be accurately known.
When was mathematics first used to predict the weather?
One of the first people to use mathematics to predict the weather was English meteorologist Lewis Fry Richardson, 1881 to 1953. In 1922 he proposed the use of differential equations to forecast the weather, an idea published in his book Weather Prediction by Numerical Process. He believed that observations from weather stations would provide data for the initial conditions. From that information, predictions of the weather could be made for several days ahead. But Richardson's methods were extremely tedious and time-consuming, mainly because they had to be done by hand in the pre-computer age. Thus, most of his calculations came too late to be of any predictive value. Richardson determined that 60,000 people would have to do the calculations in order to predict the next day's weather. But his ideas did lay the foundation for modern weather forecasting.
What is the area of a two-dimensional geometric figure?
The area of two-dimensional figures varies depending on the object. For the simpler two-dimensional figures, square, rectangle, parallelogram. The area can actually be found by calculating the number of square units in the interior of the object. Such a task can be difficult and time-consuming, so mathematicians simply multiply the height, h, times the base, b, sometimes said as length times height or length times width, with rectangles. For more information about the area of geometric figures, see the Appendix 3, Common Formulas for Calculating Areas and Volumes of Shapes.
Is measurement tied to mathematics?
Yes, measurement is definitely tied to mathematics. In particular, the first steps toward mathematics was using units and eventually numbers to describe physical quantities. There had to be a way to add and subtract the quantities. And most of those crude calculations were based on fundamental mathematics. For example, in order to trade horses for gold, merchants had to agree on how much a certain amount of gold, usually as weight, was worth, then translate that weight measurement into their barter system. In other words, X amount of gold would equal Y amount of horses.
What are betting odds and how are they determined?
Betting odds are usually written in the form RS, in which R is the chances for and S is the chances against. This can be stated as R to S or chances for to chances against, or S to R or chances against to chances for. But note that odds of 1:1 are said as 1 to 1, not 1 out of 1. Odds are usually calculated as follows: total chances equals chances for plus chances against. Or chances against equals total chances for.
What are the derivatives of trigonometric functions?
There are also derivatives of the 6 major trigonometric functions: sine, cosine, cotangent, cosecant, tangent, and secant. For more information on these trigonometric functions, see geometry and trigonometry.
What is a mortgage?
A mortgage is a method of using property as security for the repayment of a loan. It is based on a 14th century coinage of a Latin word meaning dead pledge. The interpretation was that the property was dead to the borrower if he defaulted on the debt, and the pledge was dead to the lender after the loan was repaid. For centuries, it's been figured out using mathematics.
What were the ancient definitions of a foot?
Not all feet, or the foot, are created equal. The term foot in measurement has had a long history, with many stories claiming the origin of the first foot status. In fact, it seems as if the foot has ranged in size over the years from 9.84 to 13.39 inches. 25 to 34 centimeters, depending on the time period and / or civilization. For example, the ancient Harappan civilization of the Punjab, from around 2500 to 1700 BCE, used a measurement interpreted by many to represent a foot, a very large foot. At about 13.2 inches, 33.5 centimeters, see above for more about the Harappan. Around 1700 BCE, the Babylonians put their foot forward. A Babylonian foot was 2/3 of a Babylonian cubit. There are even records from Mesopotamia and Egypt showing yet another measurement system that included a foot of 11.0238 inches, 300 millimeters. This was also known as the Egyptian foot, and it was standard in Egypt from pre-dynastic times to the first millennium BCE. The Greek foot came close to today's foot, measuring about 12.1 inches. 30.8 centimeters, a Roman foot measured in at 11.7 inches, 29.6 centimeters. The list goes on, depending on the country and time period.
How are spheres described?
A sphere in solid geometry is considered to be the set of points, or the skin of the sphere, in three-dimensional Euclidean space that are equidistant from the sphere's singular, central point. Or, more simply, a sphere is a perfectly round, three-dimensional object. The term sphere also extends into other dimensions. For example, a sphere in 2 dimensions is also called a circle.
What is plane geometry?
Plane geometry is simply the study of two-dimensional figures in a plane. Most mathematicians further define the plane as Euclidean. For more information about Euclidean geometry, see above. It examines such objects as circles, lines, and polygons.
What is a graph?
The term graph has several different meanings in mathematics. It can mean the interpretations of numbers, including bar graphs, pie charts, and line graphs. For example, a pie chart, graph, is often used to represent percents, such as a breakdown of where a taxpayer's money is spent in the various government agencies for a certain year. In analytic geometry, a graph is simply a way of plotting, thus, visually representing points, lines, curves, and solids in order to understand and interpret certain geometric figures and to solve equations. For example, solving an equation with 1 to 2 variables, usually written as x and y, or 2 dimensions, results in a curve on a graph. Note, a line is considered a curve in geometry. Equations that contain 3 variables, usually as x, y, and z, or 3 dimensions, result in a surface.
What is the story behind Archimedes in the bathtub?
Any of the most famous stories of Archimedes involves royalty. Hiero II of Syracuse, king of Sicily, wanted to determine if a crown, actually, a wreath, he had ordered was truly pure gold or alloyed with silver, in other words, whether or not the royal goldsmith had substituted some of the gold with silver. The king called in Archimedes to solve the problem. The Greek mathematician knew that silver was less dense than gold, in other words, silver was not as heavy as gold, but without pounding the crown into an easily weighed cubic shape. He didn't know how to determine the relative density of the irregularly shaped crown. Perplexed, the mathematician did what many people do to get good ideas: he took a bath. As he entered the tub, he noticed how the water rose, which made him realize that the volume of the water that fell out of the tub was equal to that of the volume of his body. Legend has it that Archimedes ran naked through the streets shouting, "Eureka! I have found it!" He knew that a given weight of gold represented a smaller volume than an equal weight of silver, because gold is much denser than silver, so not as much is needed to displace the water. In other words, a specific amount of gold would displace less water than an equal weight of silver. The next day, Archimedes submerged the crown and an amount of gold equal to what was supposed to be in the crown. He found that Hiero's crown displaced less water than an equal weight of gold, thus proving the crown was alloyed with a less dense material, the silver, and not pure gold. This eventually led to the hydrostatic principle, as it is now called, presented in Archimedes' appropriately named treatise, on floating bodies. As for the goldsmith, he was beheaded for stealing the king's gold.
What are computer codes and programs?
Mathematics is an important part of computers, because math is used to write computer codes and programs. The codes are the symbolic arrangement of data, or the instructions, in a computer program, a term often used interchangeably with software. The code, also called the source code, or just source, is any series of statements written in some programming language understandable to the user. This source code within a software program is usually contained in several text files. The program is the sequence of instructions, or computations, that a computer can interpret and execute. In other words, most programs consist of a loadable set of instructions that will determine how the computer reacts to user input when the program is running. The connection between codes and programs is often heard by students studying computer science or working professionals, and even in action movies and television programs. As in, I need to add more lines of code to the program.
What are the modern connections between architecture and mathematics?
The foundations of modern architecture began with mathematics. Mathematical planning goes into creating almost every working, freestanding structure. From the smallest monument to the tallest buildings and bridges. For example, in order to build a structure, the area where the building will be erected must be measured to see if it will fit. Measurements and surveys, then the building plans need to be drawn up in scale drawings made proportionally smaller to the structure's real size. For more information, see below, and the amount of building material must be estimated, mathematics to figure out the budget. Finally, the actual structure must be built to specifications so the building will stand without collapsing, geometry and measurement.
Who was the first mathematician to write and solve general algebraic equations?
French mathematician François Vite, 1540–1603, also known as Franciscus Vita, is often referred to as the founder of modern algebra. He was not a professional mathematician, but he contributed a great deal to the understanding and spread of modern symbolic algebra. Although some of his work paid tribute to ancient mathematical traditions, Vite created a kind of new math. It was not one based on the traditional geometric visualizations, but rather expressed as abstract formulas and general rules. But Vite still divided algebra into distinct branches partially derived from Greek mathematics. Zetics, translating a problem into an equation. Poristics, proving theorems through equations, and exegetics, solving equations. He also was the first to combine algebra with geometry and trigonometry. For more about Vite, see History of Mathematics.
How is math used in statistical process control?
Statistical process control, SPC, Involves using statistical techniques to measure and analyze the variations within a process. With SPC, industrial engineers monitor, control, and ideally, improve a process through statistical analysis. The 4 basic steps include measuring the process, eliminating variables within the process to make it consistent, monitoring the process, and finally, improving the process to make the, usually better, intended product. But it is not the answer to everything. All the SPC does is ensure that the product is being manufactured and designed as intended. Thus, SPC does not tell whether the design is good or bad, just if it's made according to plan.
What are polar coordinates?
Polar coordinates are actually an alternative system to the Cartesian coordinates. In 2 dimensions, they mark a point on a plane by its radial distance r, from an origin and a polar angle, 8. This method also uses trigonometric functions such as sin and cos. Sine and cosine. For more about such functions, see trigonometry in this chapter. Polar coordinates in 3-dimensional space, also called spherical coordinates, use r and 2 polar angles, 8. To give the direction from the origin to the point. To compare, a 3-dimensional polar coordinate system overlaps the Cartesian system in several ways. For example, 8 is the angle between the line to the origin and the z-axis of the Cartesian, x, y, z, system. Is the angle, counterclockwise when viewed from positive z. Between the projection of that line onto the x, y, plane and the x-axis.
What are scale drawings?
Scale drawings are drawings or illustrations that are proportional in scale to the real structures they represent. In order for a new building to be designed, an architect must convert his or her ideas to drawings. But since the drawings can't be as large as the building, the architect uses scale drawings to depict the structure. These miniature versions of the actual structure show the sizes, shapes, and arrangements of rooms, along with structural parts, windows, doors, closets, and other important details of construction. The scale drawings of these buildings must be in exact proportion to the actual structure, with various scales used for this purpose. For example, 1/8 inch might be used to represent 1 foot, thus, an 8-foot long building feature would be drawn as an inch long on paper. One of the most common scales used by architects is 1/4 inch equals 1 foot. These measurements can also be translated into the metric scale. Scale drawings are also used in other engineering fields, such as surveying. For example, distances measured in the field can be translated to a smaller scale. such as a drawing, in order to accurately depict what was measured. The ratio between the real distance and the drawn distance is called the drawing scale. If the measurement is 200 feet in the field and on paper the desired line is 8 inches long, then 8 inches on the paper would equal 200 feet on the ground, and 1 inch would be equal to 25 feet on the ground. This is translated as a diagram with a scale of 1 equals 25, 1 inch equals 25 feet. Or 125. There is another way of approaching such an illustration. If the longest distance measured in the field was 300 feet and the desired drawing scale is 1 inch equals 25 feet, then the minimum length of paper needed would be 12 inches, or 300/25.
Who was Sir Isaac Newton?
Sir Isaac Newton, 1642 to 1727, was an English mathematician and physicist. Considered by some to be one of the greatest scientists who ever lived. He was credited with inventing differential calculus in 1665 and integral calculus the following year. For more information about calculus, see mathematical analysis. The list of his achievements, mathematical and scientific, does not end there. He is also credited as the discoverer of the general binomial theorem. He worked on infinite series, and he even made advancements in optics and chemistry. Some of Newton's greatest contributions include the development of the law of universal gravitation, rules of planetary orbits, and sundry other astronomical concepts. By 1687, Newton had written one of his most famous books, the Principia or Philosophiae Naturalis Principia Mathematica, the mathematical principles of natural philosophy, which is often called the greatest scientific book ever written. In it Newton presents his theories of motion, gravity, and mechanics. Although he had developed calculus earlier, he still used the customary classical geometry to work out physical problems within the book.
Can a fraction's numerator be 0?
And the context of division, see above, we learned that it is not possible to divide by 0, which is labeled an undefined number. But you can have 0, 0, as your numerator, and any allowed fraction, one that doesn't have a 0 in the denominator, that has 0 as its numerator, will always be equal to 0. For example, 0/5 and 0/345 both equal 0.
What is cryptography?
Because of the extensive connections between computers across the Internet, it has become necessary to find ways to protect data and messages from tampering or reading. This includes protecting people's personal information when they buy, things over the internet and those who need to keep banking data secure. One of the major techniques for ensuring such privacy of files and communications is called cryptography. Cryptography is a mathematical science used to secure the confidentiality and authentication of data sent by a user to a certain site. It secures the data by replacing it with a transformed version that can then be reconverted to show the original data, but only by someone with the correct cryptographic algorithm and key. This is why, when ordering over the internet, it is important to see the lock icon at the bottom of the screen. This is your way of knowing that cryptography is working and the data is secure, thus preventing the data's unauthorized use.
How are decimal fractions calculated by adding, subtracting, multiplying and dividing?
Decimal fractions are added, subtracted, multiplied and divided much like whole numbers, but with decimal differences. The following gives some examples. Adding such numbers as 0.3 plus 0.2 is simple. 0.3 plus 0.2 equals 0.5. Adding whole and decimal fractions is also easy. 2.4 plus 5 equals 7.4. These numbers are also easy to subtract, such as 0.3 0.2 equals 0.1. Multiplication and division with fractions is also similar to doing so with regular numbers, although the placement of the decimal point is all important. For example, multiplying 24.45x 0.002 equals 0.0489, dividing the same numbers 24.45 002 equals 12,225. It's interesting to note here a mathematical surprise. In the last example, dividing the small numbers equaled a much larger number, the opposite of what most of us would expect.
How else is the word algebra used?
Algebra may be defined as the subjects of arithmetic and abstract algebra, but there are other meanings. These algebras involve vectors and matrices, the algebra of real numbers, complex numbers, and quaternions, an operator or factor that changes one vector into another. There are also those exotic algebras invented by mathematicians and usually named after the inventor, with the majority not truly understood except, perhaps, by their creators.